And I always like traffic wave it. Okay, I'm going to share this screen, assuming it's the one that's going to show up over here. We shall see. Before we get started, I have some awards here that I need to give out. So our first one is for Noah. Noah, would you come up here, please? I have a few. I'll go faster after I get started. And Cohen, you can take a look at it instead of being a whiny. Thank you. And Austin is not here yet. David is not here. Clint, come up here, please.
What's going on?
You'll see when you get up here and get one, okay? You go. Oh. Sometimes you just need to sit and watch. Next, Taylor. Taylor's not here. Tyler. Oh, come on up here. Tyler and Taylor. Here's Tyler. Thank you, sir. And Taylor. Thank you, sir. And Seth. And then after Seth, I have Michael. Thank you. Make you guys do your certificate acceptance properly. Thank you, sir. And Colton. And Joe. Joey. Thank you. Very good. And then I'm missing Quan. Okay, so these are your first C#2 certificates, because I know it's going to be a semester of certificates for you because you should be getting your MTA. This is for getting your rose, petals around the rose game all working and everything, because it is quite challenging. And you guys did a really good job. It looked really, really good. And I think that it was a good opportunity for everybody to review a little bit and explore some new knowledge. I like that. So sometimes people complain that I go too fast, and it's like, whoa, wait till you get into work. But the thing is, we've got so much exciting stuff to learn and so much to do. Okay, it is showing the wrong one. Yeah, and I don't think it'll let me change it, though. That's the problem. Once they change it, it gets like whacked. So it won't let me do 2 and 3 now. 2. And then what are you guys seeing on the Zoom screen? The wrong one now? Do you see this? Okay. Thank you. All right, are we on the same place there? Okay, we were looking at stuff. So you guys have seen there's a whole bunch of videos out there for this chapter. Because we have a lot of stuff that we can learn and benefit from with all of the information that's given to us in this chapter. Now, if you get your Petals Around the Rose application all the way done, step back and figure out why, what happened. Are there things from C#1 that you need to review? Should you find some material online to help you with that? Or is it just a planning thing where you need to get started on assignments a little bit quicker? In our class, it can be hard because sometimes you need a lot of time, but there's still concepts we haven't covered. So that's why there's so many videos out there, because that gives you an opportunity to watch some videos if you're ready to tackle something and we haven't really looked at it completely in class. Last time, we started on this advanced object-oriented programming slideshow, and we were talking about transformers and Transformers are just such good objects. They're such good object-oriented type objects because they're made of other objects, and they all have the same kind of functions, but they perform them differently, so they just work out really good. We were looking at inheritance. We had seen that a lot. And let's see, what else did we see? Go, it's not going to click. All right. We did this whenever we were looking at inheritance earlier when we inherited from our picture box. In this example, we have our Autobot class, and we're saying the Autobot class inherits from the transformer. Right here, this says there should be an access level there. What is this class access level if it's not specified like that? Does it end up being public or private? Private. So we have to be careful, because if we really want to be able to share this and inherit from it, we have to make sure that our access level allows that. Whenever we have a constructor in a class that inherits from another in an extended class, we're going to have special information in our constructor. It's going to have parameters for all of the different parameters involved in the constructor for both the inherited class and the inheriting. So the parameter list can be quite long. Then after that long parameter list, it's going to have this colon base specifier and just specify the parameter names, not the data types of the parameters that need to be passed to the parent or the base class. So these constructors can take a little bit of thinking to develop. And then if we create in our class a virtual method, we can override that in other methods. So in this example, we're creating, I think that should say public virtual instead of override. That's why I'm kind of hesitating. I think there's a typo there. It should be a virtual method called attack that we can override that. And that way, all of our different types, I'm sorry, let me back up. We are overriding our attack method. It is declared in our base transformer class as virtual, meaning that we have to override it in this class. And then finally, we have a transform method that we've done some other things with. It was also declared in the base class, and it was declared abstract, so we have to override or declare it.
Do we in fact have to override it if we just wanted to do the same thing as the base class does?
Whenever we declare an abstract method, and we'll do that some today, we don't give it any sort of method body. So it has to be declared in all of the classes that inherit from this base class. So an abstract just means, I don't know what it's going to be, but you have to put it in because I know you're going to need it.
So we do have to declare that it's there, but we don't necessarily have to tell it anything. We can pull that from the base class if we want.
The base class is going to have nothing, no method body, only this method declaration that says everybody that inherits from me has to have a method called transform. I just say, I've got this abstract method. It's abstract. I don't have enough information about it to implement it. I'm not going to give it a body. But everybody that inherits from it.
That's why we have to declare it in the subclasses.
Yes.
It's not actually anything in there.
Not anything in it, right. Because it doesn't know how you want to do your attack. Is this type of Autobot?
I had it in my head, and it was the other way around. I was rather confused by that.
It can get there.
Thank you.
No problem. Okay, so as we finish up talking about inheritance in this aspect here, inheritance allows us to reuse our code. Our transformer class could be extended to create any kind of transformer that we wanted. We might create a new type, a new child class that has different characteristics than the others. So a derived class contains all of the data and methods of the parent class, plus their own data and methods. So if we looked in memory and we saw that a transformer was allocated here, all of its fields, like its name, You know, it's a number of weapons, all of those things that we said a base transformer knows about. And then we come along with our child class. There is one up here. And we extend, well, this base class. So now we've got Autobot info that's attached to it. And it's all still considered one big class instance to us, one Autobot. But we have all of those pieces put together. So inheritance gives us that ability. So what's polymorphism? This is another one of those 4 object-oriented programming terms that we hear a lot. And polymorphism is just exactly morphing from one thing into another, something that has many forms. If you look at these definitions here, poly says that it's, and I'm looking at just this basic definition, many or much. So it's just a whole bunch of something. And then morph is each of several variant forms of an animal or plant. So again, that's why I like transformers, thinking about them as far as object-oriented programming goes, because they morph from one thing to another. So they're already intrinsically polymorphic. So how does polymorphism apply to us in object-oriented programming? Well, if we look at our chart here, we have our transformer class at the top, and then we created an Autobot class, a Decepticon class, and the other Cybertronian class that all inherit from that base transformer. Then we have some other classes that might inherit from those, like Dinobots are over here, and Prawns are over here under Autobots. So whenever we look at our transformer class, it has an abstract method declared called transform. Just like we were talking about, an abstract method in this base class means I don't know how to transform, but I'm going to declare that you need to, because each of you needs to know how to do your own transformation. So I'm going to declare this method is abstract in the base class. Then another Cybertronian class has to implement that transform method. The Dinobot has to implement it, but he could refer to his parent, his base implementation, right? Because there is one there. Now, besides having this abstract method, we also have a virtual method in our transformer called attack, which means you can override it if you want to. And our Autobot overrides that attack method. Both of those are examples of polymorphism, because we're saying the transform method could take many forms, right? It could take the form of a transform that's required for another Cybertronian. It could take the form of a transform that's required for a Dinobot. So that's why this is polymorphism. By us being able to override these methods, we're saying I can have multiple occurrences of this method that do different things. Now, which one is going to be executed? When we're looking at our code, it depends. But if we're in the Dinobot class and we call the transform method, we're going to call its own transform method. If we call base.transform, then we could be calling this other Cybertronian. So we can control it, but by default, we're going to be calling the method in the same class as the class that we're in. So polymorphism is multiple implementations of the same behavior. My attack behavior can be implemented differently for each of those different types. Some other things about object-oriented programming. Whenever we work with a class, we're thinking of an object. So a class is a noun, right? It's a thing. It's a person, place, or thing usually. Whenever we're speaking about a class, we could say something like, a child of a transformer is a transformer. Is that true? So inheritance, that's the rule of inheritance, right? Because the parent is a transformer, the child is also a transformer. So in the same sense as if my parents were Smiths and I was born, I would also be a Smith, right? So that's that same child of inheritance. Now, whenever we instantiate a class, we create an instance. So Bumblebee is an instance of an Autobot. Bumblebee is a transformer. So both of those statements are true. Again, we can say that because of inheritance. Now, whenever we look at data, our class fields and properties, remember those are encapsulated, all tied up within our class. So some of the things that we could say about data, data has a relationship with our class. So the class itself and instances of the class have a is a relationship. So a data field has a relationship. So in the sense of a transformer has a name, a transformer has a number of weapons. So anything that is implemented data-wise in the class is a has-a type relationship. One of the rules of object-oriented programming has to do with the composition of an object. So whenever I say it's something is a object, it is a type of that object. Whenever we say it has a, it is a part of an object. So type of and part of relationships. Yep, Austin's gonna be like, you know I was driving from Branson. He's like, you know. How'd you get here?
I went to, well, I could have taken the 65 James River, but I just said I we could close off the entire highway. So I actually went to Rogersville. I went all over there.
Oh, geez. Oh, no. It's a long morning already. There, yeah, if you miss that exit, there really isn't much you can do, is there?
Locked off all the turnarounds. So I better go back to.
Oh, my gosh. There's like, you guys can handle it. All right, so here's a line of code that instantiates an Autobot, right? Take a look at it. How can we tell? The data type is Autobot, the class name. Then, of course, we give it our instance name. Then we say this is a new instance of an Autobot, and then we pass our parameters. Because this class extends another class, we might have to have base class parameters and then our derived class parameters. So in this example, we've got our base class parameters first, you know, all of the things that have to do with transformers in general, and then we have our subclass parameters. We'll do that today. Now, whenever we are working with encapsulation, we enforce that by using getters and setters. So remember, if we're looking at Bumblebee's name, we're going to use the getter to get that data. If we want to set the number of wheels, we would be using the getter, the setter, sorry. So whenever we're looking at object-oriented programming, the code is really simple. You guys don't have to do much different than you've already done. We have to use the colon in the class name of a class we want to inherit from. We might have to use the keyword abstract when we define a method without a body to say that classes that inherit from this class have to declare this. But we really don't have a lot of new code here when we're working with the advanced class capabilities. But we have some concepts that are important to really get down. So remember, abstraction helps us get down to the most basic pieces. It's abstract. We don't have to worry about the details. Encapsulation helps us hide those details within our class. Inheritance allows us to use those basic details and add more. And then polymorphism is An example is being able to use the same code for multiple forms. So we've used polymorphism before. When we're working with C#, let me switch it here. This one's just a couple slides. We were talking last time about layering our applications. And I think it was Cohen said, is this like MVC? And it is like MVC. MVC is a high-level application, how do I say, implementation type methodology for C# and .NET applications. So .NET applications are things that are web-based, that are running C# behind the scenes. So whenever we have that kind of application where we have some really high-end things going on, we usually have a database in the back end behind the scenes. And we'd like that database to only be being accessed by a data access component, a data layer. Now that data layer is going to be driven by a business layer. And that business layer is going to be like our class code, like, you know, this employee, we need to go get that employee data from the database, or we need to update that employee data from the database. But it's all coming from our class code. Now, all of the business class code is going to be driven by the user. And the user is going to be sitting at some screen saying, I need to update this employee, or I need to see this employee. And we're going to be responding to those requests. So we would like that user to be on their own layer called the presentation layer. And we're going to work towards that this semester as we work with C#. And when we get to our database access, we'll really start enforcing trying to separate out our different layers so that we have component-based development completely. Now, the 3-layer model is presentation layer, which is our user stuff, the business logic layer, which is a lot of our class code, and then our data access layer, which is all of our database SQL code and classes that help us access the database. I have a friend who's in development. She says, yeah, there's like a 5-layer model now, is what everybody is striving to achieve now, is adding in a couple of additional layers to further split things. Why? So I can effectively allocate resources as a business. If my database server is not being able to handle the load, I can update the hardware for that, or update my Amazon web plan, or whatever the case may be.
What are the other layers?
No, I don't know. I didn't ask her. I was just like, no, I don't want to know right now. And she said, yeah, it's way out there. I was like, quit bothering me. So, yeah, I think it's like, gosh, I don't know. Probably the front end, like splitting out.
No, you can probably combine. They probably split the business layer into another one.
Yeah, something that's a little separate.
Something like output, maybe input, something like that. Split it up like.
I'll ask her and see if she can remember it. It's been a couple years since she's worked with that stuff. We'll harass her. I'll ask her. So we have a need to know now. What is it, Teresa? But yeah, she for several years did server maintenance and things like that. And again, if our user is having issues on their local machine, we can handle that very easily just by updating that machine. So we want to keep those functions separate. Another thing that benefit that we get from this is added security, because now we've got things where, you know, our database people can have access to the database and be handling those kinds of things. And our software developers can do our business logic, and our marketing department or whatever department is responsible for the website can take care of that without crossing over too much. In the videos that the Google Doc form thing sends you to, the videos kind of give you an example application, and that's why they're in videos, because it would take us so many class periods to do that all together. We're going to do pieces of it, but I wanted you to have all of it put together. The application we're trying to create has to do with people and students, and so as we start creating our 3-layer app, our first thing that we would want to do is create a class to define our student. So all of our data is going to be declared in our class, and we're going to know what a student object looks like. And that would be the beginning of our endeavor. Now, whenever you guys create an application, there's been a couple of times I said, let's go to the folder that your application is in. Now we want to go into bin debug. And in that bin or bind folder, you'll see that the .exe to run your program has been created in that folder. So you could take that exe file out and put it someplace else and just double click on it to run your program. And as we start working today, you'll see that in that same folder, if we create a dynamic link library, the DLL file will be compiled into that bin debug folder. So we want to try that today. Now, a DLL stands for Dynamic Link Library. Just mentioning last time, this is a way for us to share our code without sharing our source code. So if you're going to work with me at Walmart and you're going to be an EDI vendor, you're going to send me stuff or sell me stuff, then I'm going to give you an API, which might be a DLL file for you to implement into your C# programs. And then you're going to have ability to use my class, my logic, my data in your programs, but you're not going to have my source code. So it gives us a lot of capabilities. When we work with DLLs, there's a few things that we need to be aware of. Whenever you're working with TFS, remember, it's a source code control system. A DLL is object code. So it's not going to be checked in to TFS because it's not source code. So your DLL will have to be recompiled if you go to another machine or done something else with. So it's not going to just stay there and go to TFS for you because it's not source code. So in the videos, you saw we're working with a person object, and from the person object, we derive a student object, and we have a career center student and different students. So we've seen that we can take that base class and derive it into other things. For you guys, for your homework for tomorrow night, or Wednesday morning is actually when it's due. Now I've changed all of those due dates into Wednesday morning. Whenever you're working on your homework, you're going to be creating a team-based class, and underneath it to derive from it, like a football team, maybe a soccer team, 2 different teams. So what could we create really fast class-wise that would be something that would be interesting? What would you like?
Foxes.
What?
I said foxes.
Foxes? No, I can't derive from a fox very well. I want something like we could do animals.
We do video games. We do like video games, stuff like that.
Let's do that. Let's do video games because I have those other videos where I do animals and cats and dogs and stuff. So I hate to redo what we have in the video already. I know you guys, 700 hours worth of videos out there. Well, if we did that, if we did a video game, what would our base class be? What are you thinking? What would our base class be? It's a game? A game? And then what kind of child classes could we have? Do you think of right off the top of your head? Because we'll just do a couple.
Tabletop as opposed to computerized.
Oh, that's a good idea.
And computerized, we could do types of or genres and like what
Shooter
platform
games.
sports games. Yeah, what platform too? Off that to electronic. We wanted to.
Because
Yeah, that's who the platform.
Because I don't really need to inherit that. We could make those just be fields. Platforms. Because you could really have multiple platforms.
Yeah.
So we could have like a list or something and check boxes where you could check which platform it applies to instead of just like one platform. So that would be good. So we could have some check boxes here for platforms. What about our game object itself? What kind of data would we like to have for it? Name?
Developer. Like, I guess you could do like release dates and stuff like that. If it's like depending on where you're at, if the game's not out yet, that would be more relevant. Version. Yeah, version.
Version.
Need a bigger box.
If we really wanted to, we could do price.
So that
Well,
would
it wouldn't
vary.
really be,
That would vary.
yeah,
Not
because it would be like,
what we call video games on Steam. They're still $60. Buying used for $15 a game.
we could do those distribution. Like, is it going to be in the stores or is it going to be?
Would that just be a checkbox as well? Or?
Yeah.
Yeah, we could do anything. We could have a list of things, or
So this is all like internalized.
There's properties.
we would set it up how we want. And then what about tabletop games? What kind of things do we want there?
You could do like, again, like types within that, like it's a card game or a board game or.
Yeah, what would you call that? Just type?
I guess. Like, or format maybe?
Format.
Yeah, like what format of game is it like? Or you could do 3 different classes because they could each have derived from it.
Yeah, from it. So you could keep going class-wise.
Yeah,
And that's just design decisions that you have to make. Well, if we did format, let's do like max number of players or something like that. That's good. That gives us a couple of fields for each of our subclasses and several for our base class, because remember, we have to declare all these. So we want to keep it to a small amount. Let's do it. Let's create this thing. Now you're going to have to help me because I can't see it from over there. So I'm going to come to Visual Studio, and the first thing I want to do is I want this game class to be a class library. I want to generate this, compile this as a DLL, and then I can send it out to my developers that are going to be working on these various subclasses that are going to inherit from this base class. So this is our first thing. We're going to create this first. Our person that has been with the company for 27 years and has all the experience gets to do that. That's how it always works out. Okay, let's create one. So I want to create a new project, but I want this to be a class library. So if you look through your different templates, you'll see class library. And we remember we want to use .NET Standard because .NET Framework is the newer stuff. And I think all that stuff is installed now on these machines, but I'm not sure. So we'd better not make it. Do what? Do you see it? Okay, so this class library is going to hold our game class. And I need to give the name of this project, this is going to be my solution name, something meaningful that's not the same. So let's make it be like game app. Now I've got my create directory for solution. Ooh, I'd like to add this to source control. And you know, I didn't make sure I was connected to TFS first. Dumb, I better cancel and go to Team Explorer and make sure I'm connected to TFS because I don't want to throw this into GitHub. And so I'm going to connect. I still haven't taken a video of how long it takes to connect from home. Does it take you guys that long at home, like 20 minutes? Just because because I'm switching like from one person to another, just trying to get your guys' mapping set up, and it takes forever. Look, it's going to take forever to do it here too. That's why I never get it set up. Yes.
So I watched that video on what you were making the student class,
Mm-hmm.
and you used the universal windows instead of the .NET standard. What's the difference?
Good question. The UWP is our the UWP apps use XML-based forms instead of Windows forms. So XML-based forms are more like tagged, so a little bit like HTML. You know, there's XAML, XAML, so they're consistent with the Java forms, and they're more dynamic. So it's definitely something to take a look at. We decided that for the C# classes here, we would continue focusing on Windows forms because you guys see that so much out in the world, but you can definitely switch over to that UWP real easily. Okay, I'm going to find my stuff here. Sorry for the delay. Yeah, mine's just really angry. I'm just going to do this one. It just takes forever. Yeah, I wonder if I deleted all that stuff, if it would get better. Okay, so finally, I'm going to create my new project. Class library, .NET standard, game, app, add to source control. Okay. Now, when I look at this, can I just rename my class right here? Because I want it to be class game. Or do I have to right click and rename it over here?
You have to rename the file too, not just the code.
Good. So annoying. Now, I want to do this really quickly. And I'm going to right click on my game.cs file. And I'm going to where are you? It's not, it won't show that class. I wanted to use our fancy class generator and it won't. Okay, so we're gonna have to do it on our own. So what do we have here? First of all, they named this a public class, so that's good. And we said, you guys have to help me. We have a name and a developer. So I'm gonna do private. Yes?
I don't know how big of a deal it is. Is there any way you can make the text just a little bit bigger?
How's
Thank
that?
you.
Sure. You just say the word. I was watching my Java classes videos over the weekend, and I can appreciate needing bigger text, that's for sure. Some people I couldn't see anything at all. Date release. We're going to use a date field. We might regret it, but let's try it. What do we call that? Date released. I feel like she has a ant memory. Okay, so we're looking good here, getting us some fields. Version, distribution. You want your version to be a string or an integer, or what do you think?
I do a string.
You're a string?
You're not gonna need to add. Well,
You might make it be V1.75.
I mean, if you're doing all numbers, I guess you could do it where you can add that decimal to it.
Yeah, I would say probably a double then.
But if you're just doing, yeah, it just depends on
How you do it?
how
Let's make it be an integer, and then we'll pass that. The last one is going to be distribution. So we'll try some different data types here. Let's make our version be an integer.
I mean, like, but what if we have like a board game name, like Games Edition or something like that?
They what?
Like board games, they don't necessarily have like different versions, like 0.10. Like,
Well, I mean, as far
So
as
does
the
that
class
not,
is
does,
concerned,
so
that's
does this not belong in this class? Should it be down in our electronic games class
Well,
instead of this
you're
class?
right, but you could still have a version of this one labeled the same way. Like they can improve the game by making like a second one, but they won't usually don't name it like version 1.2,
Right.
advanced or
Mhm.
revised or something like that.
Well, we could make it a string, but we're already passing around a bunch of strings. So let's just make it an integer,
And
even
then
though I agree with you completely
maybe
that,
our subclass can have a thing that says, here's what the title for each version is. rather than
yeah,
just
that's a good idea, like title,
because
version
as far as the game class
information.
is concerned, it doesn't really care what the different names for the different versions are.
Right, I just want to have some different data types to pass around in our constructors. Okay, so now, remember I've got this little screwdriver quick action thing here. I'm going to use it, and I'm going to encapsulate my fields, but still use the field. Now, notice it's only doing the name, so I want to select them all, and then I can do encapsulate fields, but still use field.
What's the difference between the one that's I didn't even know that was a property?
If we just used properties, then all of our data fields would become public, and we wouldn't be able to save any information in our class privately, because anybody would be able to see everything in our class would be public in a property.
What is the format for naming things in private? Because I've seen some where it's underscore and then the name to indicate that it's a private field.
So the way we were told, which I'm sure could be different, is that the private data fields are supposed to start with lowercase letters, and the public properties are supposed to be exactly the same, only start with an uppercase letter. And so that's the C# convention if you search online for stuff, but I'm sure you'll find lots of other really good conventions as far as doing it. So that's just how we've been doing it. Now, also, we've got these Lambda expressions here with our properties, and we've seen that sometimes those aren't supported by our different compilers, but that looks pretty good. Now, I'm going to select all these again, and I'm going to look at my quick actions. And this time, I think I'm going to generate a constructor. So I'm going to generate my constructor for game, and it's going to have all of my fields as properties. Now, it put that constructor above my properties, and I don't like it there, so I'm going to move it. Control X, and then I'm going to put it down here after my properties.
It's so easy and convenient.
Now let's clean some stuff up here. First of all, above my class, I'm going to do the 3 slashes and put some generic information about our class. This class defines a base game. Go ahead and put your name and your date.
How do you get the constructor?
What do I highlight?
And remember, the little screwdriver icon that we're seeing here is from the IntelliJ people, IntelliJ IDEA, because we have all that software installed. At home, you're just going to right-click on that stuff, and it's the first option under Visual Studio if you don't have the IntelliJ products installed.
Usually, that shows.
On Visual Studio also.
I don't have the HTML constructor.
You don't have it?
Yeah, I just got it have to like.
Select them.
That one.
I don't know why it's like it's not installed on yours. Yours is such a tight fit. No, keep that. That's what you want. Right click. Right click on it. Escape.
Get the construction.
I don't know why it's not connecting. You could delete those and try it if you wanted to see what I'm on. It shouldn't. You just have to type it. Have to make your own constructor. How awful. Okay, so we've got some comments here for our class. Now, inside of our class, I want to put that # region statement and say private class fields. Nice, thank you. That's perfect. And then I want end region and private class fields. Now remember these class fields, we could also call these instance variables, because remember they're going to be unique for each instance of our class. Okay, then I'm going to do a # region for our public properties and end that. And then we should have a region for our constructors. And I'm going to go ahead, oops, I have to put that word region, it's so particular. And then I'm going to end region there. So in this constructor, this very first constructor, we need all of our data fields. So I'm going to zoom out just a little bit, and I'm going to click here at the beginning of this class header and press enter to open up a line, and then I'm going to do the 3 slashes to create that comment. Now remember, since I did the 3 slashes, Visual Studio is generating these XML comments, and these XML comments are already filled up with what the parameters are that we are expecting. And you're going to see these comments show through when you implement this base class in your derived class. You're going to see how they are going to be carried through to the developers that are using your class. So what do we want to say about this constructor? A fully populated game instance constructor. How's that for a comment that is like, what? Why is it fully populated? Well, because we're going to use every parameter. We're passing in everything for that game instance, and it's our constructor. Now, we could create some additional constructors to allow flexibility. So let's copy that. I'm going to go ahead and label this closing curly brace, end of constructor. then end of class, and finally end of solution. Get all of those marked. Yep.
A quick question.
Uh-huh.
Because it occurs to me that it's probably a good idea to make a no-art constructor as well.
Yeah.
But I don't know how to format the default value for the date released one.
Yeah, we'll probably have to do some Googling. I think that's a great idea. Let's get with him. We want to know our constructor. So I'm going to do public game with no parameters. And so then what do you want to set our name to? Default name.
Yes, game.
Game.
The game, which you have no loss.
Did you guys ever play that stupid game? The kids in Carthage had that weird game where they would hit each other when they saw a UPS truck or whatever. It was the game. I don't know why. For many, many years, it was scary to ride on a bus because when you saw UPS all. Yeah, well, I figured it was just okay, so what else do we have here? Date released. So how do we format a date? We could just say now, but that wouldn't be valid, would it? Because they might actually want it to have some other date. So let's see what we can do. I'm going to Google this. C# set date time. .NET Pearls has some date time examples, and I like .NET Pearls. They usually have some pretty easy to use examples. Oh, there's one. Date time value equals new date time, and then they just have the year, comma, month, comma, day. So let's see if that'll work for us. New date time.
Is actually a class.
Yes. So we want year, month, day.
Okay.
Too easy.
Now, would we want to set the default date time to today's date, since it can't be made before today?
It could be. So would we want to do that, or would we want to set it to some specific value that we could search for in our database to find all the ones that weren't specified? So there's two different ways of looking at it.
Why can't we set it to a day before today?
We could set it to any date we want.
We could set it to 1999 on Christmas.
We could do that.
As far as this one is concerned.
Do you think that that would be, but that could be a date, that could be a date that some were actually released? So we'd want to come up with some sort of date that we think that wouldn't have been used very often. So we could search our database and find all of those so that we could get them fixed. So if we use date time now, we would.
I'm talking about today's date, not date now.
That is today's date. But if we did that and then you created a date and then you created one tomorrow and then you created one the next day, would we have a way to query the database to find all those that need to be updated whose release date is not correct? We wouldn't, because we wouldn't know what date they were created. We could maybe have some other way to find them. But do you see what I'm saying? That in our default, we want to use something. So maybe 1901, 0101, how's that?
Well, if we're going to go that way and just push it that far back, let's go really crazy and make it 1601.
I don't think we can go that far back.
How far back would let's go?
You'll have to try it. I do not know. It might let you go back that far.
There's definitely not anything that should have that date on it. As far as this class is concerned.
Now I'm going to go ahead and comment this new constructor. We'll call this the no-R constructor of a default game. Yes?
Do you need the default one for the version of distribution?
Yeah. I got done, didn't I? unknown. Is that how you spell unknown? You know how sometimes your brain just goes, "What?"
You can make distribution chart.
Oh, it's mad at me, huh? Okay, so let's say then we'll make it U for unknown. So what are our distribution codes going to be then? We'll say U equals unknown.
We have like
O equals online, like O equals online distribution.
Online, or do you want one that specifically says, huh? Okay.
I guess you could do because we could do multiple characters. We could do like OE for online exclusive.
No,
that's fine.
characters have to be one letters
Yeah, that's fine.
because it's a character.
And then
Lowercase e or b.
is B brick and mortar, is that good, or would you have it some other
Yeah.
code?
Or retail.
Retail?
And you could have like a lowercase before. You could do the uppercase B as brick and mortar exclusive and lowercase b for. It can also be something that you could do one for like both, something like that, where it's
Yeah, so we could set that up however we want.
I
That'll be good. That'll give us some options. And we'll just say that U is unknown. So we're going to do that one here for this constructor. So that's probably a good place. Now, we could put it up at the top of our class. We could also put it like somewhere within our distribution area. But I think at the top of our class would be good. I'm going to put it after this summary and the distribution methods. We'll make it big E is online and little e is online exclusive. I'll change it a little bit so that we're more consistent.
Wouldn't the lowercase like having one of both? They can't be online and brick and mortar and not be the both category, right? So it's almost be irrelevant. Like
Could be.
uppercase. We'll need something that's like both.
Both.
Like, because
Well, we're going to make it check boxes so they can check whichever ones they want. No, we made it a char, so we can't do that. So it's gonna have to be radio buttons. So do you want all A for all of the above or something? All methods. So we won't be exactly perfect, but it'll give us a chance to experiment with it.
It'll be okay.
It'll be okay. Of course, we could get really, really involved with it. So now looking at our class, everything's looking really good. We have our data encapsulated within our class, and we have made it accessible outside. And we need we've got one constructor that requires all parameters, one constructor that doesn't require any. We might at some point decide that we should have one that's kind of in between. But let's add, after our end of our constructors, we need some methods. Methods for the instance. So the first one we need is public override to string. Now in our toString, we want to return all of these items that we've already got in our class. So I'm going to allocate a string variable and start out with it blank. Then I'm going to add to it and we want to use those interpolated strings, right? So I want name and then name. And of course, you guys could do this any way you like. I like with our interpolated strings how we can have a different line of code for each of our data fields, and we can make sure that we've got it all nice and clean. Date released. Now in our date release, we're going to have to do some testing because we might need further information to properly format that. Then our version. And finally our distribution. Now the way I have this right now, it's all going to be on one line. It's going to be smushed up. Do you want each of them to be on their own line, or do you want it to just all be in one line? Separate lines? We'll put a \n on each of those then. And then we want to return our return string. Now to document our toString method, again, if I press enter up here and do the 3 slashes, it puts in the returns clause for us. toString override to display game as a string. And then I'm going to put returns, return string. So we need some methods so that we can try implementing things. What kind of things could we have behavior-wise for our games that we would be able to override at the lower level? I guess we could say how to win. Would that be something that we can choose? Do it. Instructions, I think, are a good way. Because we could just display instructions,
Or you could do like summary, like
game summary.
Like for like the tabletop example, I think like the full instructions would be a little much.
Right.
But like if you like summarize, like you know how games have like summary in the back of like the goal, like not the exact how you win, but like kind of like
What you want your customers to see when they pick up the buttons.
the fun part of the rule. Basically.
Okay. So that's going to be an abstract method. Remember, abstract means it's going to be declared up here, but not implemented. And it's going to have to be implemented in each of the subclasses. So that sounds good. What's another one that we can have like a default up here, but then override?
MSRP maybe?
That sounds good. So we'll make that one, I'm going to make it be display also. And that'll be virtual so that we can see the difference. Okay, let's put those in.
The virtual is hardly out. What is it?
I'll show you. We'll do it. Okay, so let's put these in first in our base class. So after our toString method, we're going to create our virtual method. And this is going to be display MSRP. And I'm just going to return this message that says this is the default base MSRP. So in this virtual method, let's put a comment. Virtual method has a body in the base class, can be overridden by derived classes. So it can be, but it doesn't have to be. It's optional. All right, so they can if they want. So it's kind of like the toString. If we don't override it, it'll still work, just not what we want.
Question about that.
Uh-huh.
If we do override it, does it still have to return a string?
Yes,
Okay.
it will still have to match that same pattern. That
So we
same
can-
that same footprint kind of the method will have to match exactly. So just like when we do the toString, we can't return some other type of data. Once we declare this virtual method, they can't either. So
if
good
we wanted it-
question.
So if we wanted it to return, say, a double instead, because MSRP is a currency amount, we would have to decide that now, is what you're saying.
So do we want that to be a currency, or do we want it to be a string that says, here's the amount? You would have to make that decision. So either way is fine, but you should decide. That looks good. Okay, so let's do our other one. Oop, I want to put the comments up here. Method to return the MSRP. And it returns, I'm just going to say a string. And you could use that however you wanted to documentation-wise. All right, one last one. This is going to be our abstract. And our abstract class is also going to return a string, and we're going to call it display. What do we call it? Summary. Thank you. So I'm getting an error. What kind of error is it giving me? No.
You can't have an abstract method and non-abstract class.
So do we need to make this class abstract? Yes. Because if we're saying that we have this method here that we don't know how to implement, that means we can't create an instance of this game class and have it have meaning. So we need to make this an abstract class. So we want to do that on our class statement. We're going to say public abstract class game.
Mine came up with it. Now, mine for a while was just like, no, you're good, man.
What do you just do?
Now mine's mad about, I got to put in the end region and then it should be happy.
Yeah, I saw that at the end of
It's like mad at me.
just the very end where one.
Yeah, one thing.
Like, hey, hey.
Okay, so what we added in was this one line of code, public abstract string display summary. So it's the method signature. It's saying this method is too abstract for me to implement at this base class. I don't know what it's going to be, but every child of mine better implement it because they know what it needs to be. So look at the syntax here. Keyword abstract, then the return type, then our method name followed by our parameter list. We might have a parameter list there. For this one we don't, but we could. And then semicolon. So no open and closing curly braces because there is no body for that. Now let's put some comments there. And we'll say method to return a summary of the game. And then put any comments you want about that being abstract. Now, because this is a class library, a DLL app, I can't really compile it. I can't test it. So I can build it. If you look at your run menu, if you go ahead and click start, it'll do some stuff and then complain to you. You have to add some things to actually execute this project. Okay. So what I'm going to do instead is use the build menu. And on the build menu, I can build my game app. Down here at the bottom, I see the message that says build succeeded. So now I should be able to find that DLL in my bin debug folder. So you know I like to right click on my solution up here and choose open folder in File Explorer to get to my project folder. Now if I go into my game app, in my bin folder, in my debug folder, in that folder, I see my game app.dll.
Earlier when you create a project, did you do the library.net standard?
Uh-huh.
But mine on my solution part, it shows different stuff. They got the bin folder and the object folder, and there comes the file and one button that looks different, and I don't have to do stuff. I don't know, just everything is just different.
Just copy it and create one of those, the other
Net
project
standard,
type,
right?
.NET standard. Yeah, because you might compile in a different way. Now, while Quan's doing that, think about this DLL. I'm going to take this DLL and I'm going to include it in another project. So that means this other project is going to be dependent on this thing. What if I come back then and change this? Is that going to impact that other project? It could, it very well could. So I shouldn't just leave this DLL in this project folder. I should put it in a safer place. So what I should do is create a library for myself, for my company of DLLs like this, and keep them safe in this library. Then if I really want to change that DLL, I can copy a new version of it into my DLL folder and then affect all of these applications that are using that DLL. But I don't ever want to use a DLL just directly from the folder that it's being created in. If we do that, things will be much easier. You guys' stuff will be much smoother. It'll flow right on through. But think about if you were in the real world and you updated that DLL by mistake and it affected 700 other applications that all then immediately started crashing because now that DLL has been updated. We need to have a DLL library. So I'm going to create a new instance of File Explorer. Just open it again. And I want to create a DLL library. I'm going to create it on my documents. And because our documents now is being mapped to OneDrive, this will mean you'll be able to get to these DLLs from home if you need to. In the past, we've had kind of a problem with that. But I think I'm going to just on the root of my documents folder, I'm going to create a new folder, and I'm going to call it DLL Library. Now, in reality, in a company, this library would be really, really secured, and there would only be a couple of people that had access to it. And we would have to give those people our DLLs that we've updated and say, will you please put it into the DLL library? And then they would do that. So we would have some sort of check-in procedure to make that happen.
Let's suppose we were making a DLL that's intended for just anybody to use. Would maybe something like a GitHub repository be appropriate then?
Sure, but remember, a repository is for source code. So you're talking about object code here. So no, a repo is source code control, GitHub source code control. We're talking about object code. So you could, in a sense, but realize now GitHub isn't going to be able to read anything in this file. It's going to be very confused about why this file is out here. It's not going to be able to, display anything to you about it because it's object code. Can you open that file? Let's copy it.
What were you doing after I asked you, because I was trying to copy those stuff?
We just created a folder on our H drive called DLL Library. And now we're going to copy and paste that DLL into it.
We don't want to just take it out.
Right, we're just going to copy it.
What would happen if we just took it out?
It would be fine. It would be fine. Yeah, because you won't be using it in that project anyway. But now I've got it in a good place. I can refer to it. I can get to it. So the next thing I want to do is create one of the drive classes, and I wanted to give you guys time. We're not going to have any. We'll see what we need to do. So I'm going to close this solution, file, close solution, and I'm going to open a new one, new project. I want it to be a class library, .NET standard. In this one, let's create our tabletop. And I'm going to rename my .cs file.
Where did you save this project? Was it just in the same folder as?
Yes, in the same folder.
What type of did you do a class library on?
Yep, class library again.
And would this one still be in our folder manager? This one would just be.
Yeah, you can, I left mine still under TFS control.
But did you put it in the game app folder with it, or?
I think I did. Either way is fine. But I put it in my game app folder on TFS. Okay, so here's our tabletop class. We remember that we have to inherit, we do the colon, and then our class name that we want to inherit from. Does it like that class name? It's like that class doesn't exist. So we need to establish a dependency. This application is going to be dependent on that DLL. Do you see dependencies there? Look, it's the only other thing in our project, so it makes it easy to find. Don't get dependencies confused with the resources that we were using last time. Dependencies are things our project is dependent upon. So let's right-click on that and add a reference. And a reference is just a connection to something that we're dependent on. Now, when you look at this reference manager, it looks pretty blank right now, but that's because we're of where it's currently viewing. So if we looked at some of these other options over here on the side, we'd start seeing a little bit more things. There's some stuff. So these things, all of these libraries are things that we are dependent on or could be dependent on. But we need to browse. Where am I? Sorry, it's moved. I have to look at my screen. I can't see it up there. If you look at COM, man, you see all sorts of stuff. So we're going to browse, sorry. And we want to browse to our folder where we copied that DLL. So I want to actually click the Browse button. And I saved that in my Documents folder. And I named it DLL Library. And there's my game app DLL. So I'm going to add that to this project. Now it should show up under the recent references.
Slow down a bit. Where are we getting it from?
From our DLL library that we created and copied it into.
Right.
Are you finding it?
No, I didn't do that step yet, and I'm not actually finding the compiled DLL thing from the solution folder either.
Looking at your bin debug folder, then I think there's some other folder in there. Doing these things.
Did I miss a step?
No,
Yeah, no, so not this one. Okay. And I wish we could let me have more than one thing.
Yeah, we need some other people here. Well, he's getting it. Let's embarrass our other people. Did we have Austin? Austin, come on up, please. Yeah, that's what we need to use it. Thank you, sir. For being a potentate of the rose. And then David. Oh, we have Kwon. He's like, don't make me laugh. Okay, Seth, we'll get you. Let's go ahead and click OK.
I've got a question again.
Uh-huh.
My solution explorer is so different than yours again, and I just created twice. I don't have the
You don't have it?
the BSPSCC in the tabletop process. I don't have that.
Okay, hang on and we'll get you fixed. Now, I'm still getting an error. What could that be?
Well, using game app.
Any of the names this class has to be interactive well.
There you go.
The other one's abstract, right?
So now what's it mad about?
It's not abstract.
Abstract, display summary. It says you've got to implement that method.
You forgot to use override.
Happy there? Better. Okay, let's get everybody help then. Now, we're going to leave it like this because this is pretty much what you're going to have to do for the stuff that's due Wednesday morning. So for your sports team, you're going to create the base class with your like sport or team or whatever you want to call that class. What kind of things would you want to keep track of for all of the teams out of school? Can you think of things? Name?
Number of players, coaches.
Couldn't players be a derived class?
The way they want it is that the assignment wants your derived classes to be types of sports. So it wants it to be like soccer and cheerleading. And notice I throw cheerleading in there because it does not agree with any of your other sports about extra things. You guys do any two sports that you like. And I've seen some really cool things that people have come up with as ideas for how they can enhance this derived class. So for like soccer, what's the thing you need to know about soccer that is different than the other sports?
You kick the number of players.
Do we have that up there? You kick the ball, what would that be? Movement?
Or objective.
Objective?
Type of ball. All objective is a win.
It is. Now we could have a method that is like scoring mechanism, right? And then soccer could return goal or whatever, and cheerleading could return great cheering. I don't know what their scoring mechanism is.
Do they get points based on something?
Based on stuff. Yeah, so there's things that they do. So like for cheerleading, we could have all sorts of things that would be separate. Like we could have the number of uniforms that they have, right? Or we could have different things like that. What else? Some people have said that for soccer, we need to know like how many fields are available or something. Like that seems to be a big issue with soccer. How many fields there are and how many teams there are or something like that.
Each one kind of budget. You could have type of field, you can play like astroturf, ground grass.
Type of field, I like that. That would kind of go at our team level though. So as you guys get to working on it, you'll think of things. And it's okay if you change these. So for this Wednesday, your base class and your 2 derived classes are due. They can be very short, like these that we're doing. You don't have to have a lot of different data fields, just enough to establish that this class exists, and then the derived class also exists. So Wednesday, when you turn these in, we might spend a couple minutes just like looking at each other's ideas, but we're not really going to do be code review or anything because we can't test these yet. And then we're going to be working the rest of this week and next week on establishing our tester so that we know how to test them and make everything work. Questions about it?
whenever we're making a virtual one, when would we choose it to be a virtual instead of a private variable?
It's a really good question. To me, it has to do with how much information you have about that versus how much information the derived class has about it. And so you want to make it virtual if it's something like in our transformers thing where every single type of this object is going to have a transform method, then we want to make it abstract because we don't have any idea how any of them should do it. But we know they all should. But if we had a basic idea, then we would make it, we should make it abstract because we want everybody to have to do it. But if we have a basic idea of what's going to happen, and we're going to allow that, we can make it virtual where people can override it if they need it to. That makes sense. So try working with them a little bit. But that's what we need for Wednesday morning. And I was trying to use that code builder thing, and I don't understand why it's not showing up for the class library. So I'm going to real quick create a new project. So if we do new project, and let's say I'm going to create a console app .NET Core, and I'm just going to leave it named console app 1. If I go into my console app and add a class game, where has our class diagram tool gone? Does anybody have it? If you right click. No. Because that's why I was planning on us being done really quick because we should be able to do this.
What's it called?
It is class diagrams. Install the class designer component. Oh my goodness.
Well, if you go to view_toolbar,
Mm-hmm.
you have class designer.
Let's try it.
There, like you go to view and then toolbars. Almost all the way to the bottom. And then there should be class designer.
I don't see it.
No, it's in tool, like, so go to view and then another subcategory toolbar, one more down. Or one more down. Toolbar and then class designer. I don't know if that's what you want.
Let's try it. No. Okay, so it looks like they've got things where we have to install it. So come with me. Go to, let's see if we can do this or not. On your tools menu, we want to try get tools and features. Under tools, get tools and features.
No, I mean, what are we ultimately trying to do at this moment?
We are trying to get the class designer. Did you guys get this? Update it before install? Okay. Well, I will try that and let you know. So at home, if you can remember, if you right click on your class file and show in that class diagram, down at the bottom, remember had all those little things where you could just type in your data fields and your properties and everything and it would generate all that code for you. So if you can find that thing, that's what I was thinking that we would do today and go really fast, but no, my plans were slow. So, okay. So anyways, if you can't find it, you have to do it by hand.
I cannot get it installed here as before the active user.
Okay, we'll get you fixed. That's it. Any questions? Lots to do. Think about your sports. Let me know if you run into trouble. Okay. Get you fixed. Did you update? Was it fast? Oh, okay, good. I didn't want to click on it because I figured it would take 2 hours. If you don't have security, you should. The only difference yeah, that's all we had. So it's just object browser to show you exactly what's in that file. I need to email this. All right. Did everything fixed? So I don't know.
We just update. Thank you.
You are, thank you very much. New art system, if you are. Or something wrong like that. You just have to look at it outside.
It's like the simplest thing.
No, it's not. A lot of people.
What I said, it doesn't have. Because we have to make two subclasses. Okay. And the base class should share something from here, right? This one's over here. Okay.
It should be like the game here. No.
This one right here. You have to put those column base, something like that, for the subclass, or no?
No, just so long as you.
We still have those data fields.
Yeah, as far as your constructor, you might have to on your constructor. So
For the subclasses.
yeah, depending on how you're doing. I'll post that to the Discord about how to set up the constructor because I think that would be good.
So in this, you're mostly, do you want us to actually make a running program that like calls a two-string method of your classes, or do you care more about construction?
What's it say?
Well, it says we need to make a two-string method, but I'm confused on whether or not we should make a program that calls.
Well, look at your upcoming assignments then, because it should be really clear. That's David back there in the back. Are you feeling better? Good night.
Sorry.
So what do you think?
So, here you want me to turn in the sports team like base class here while I turn in subclasses here.
Yeah, and you're not going to create a tester yet as far as to turn in, but if you feel like you would like to have a tester, you know, you can show you that, but you won't have to turn it in until next week.
Either way, I need to put it all in a TSF file.
Yeah, and actually, it becomes kind of a mess trying to decide where to put everything. So we'll just be flexible about it, because by the end, we'll just want to copy all of our different classes into one application to create the final one instead of trying to use the DLLs and everything, because it gets so messy.
So like for the TSF, do you mind if I just make a new program and just have all of the different classes in that?
That's great. That is perfect.
So the abstract class, the class containing all the classes.
It's a class that defines stuff for other classes to use. So it doesn't know how to create an instance itself. It doesn't have enough information. It's too abstract. But other classes can extend it and use its base definition.
So for example, the potatoes around the road, if you make an abstract class, what it would be?
For that one, since we were inheriting from the picture box class, it doesn't really have a good abstract class example. I guess we could say our like we could have created a base class that was a die, and then our die D6 class could have inherited that. Yeah, and then a die D17 or whatever could have been the individual. So that would be, we could have done that one, and then that would have made it abstract. Does that make sense? Because how many faces does it have? Have a great day.
This updating, can I just leave it like
I think so. Is it taking a long time?
Yeah.
That's what I was worried about.
because they have not done my TMS since last week or was horrible to me.
Was it?
Yeah.
Just everything?
Yeah, it started being better last Friday after like 6 day. Like 6 day before it was the same. Like last Friday was a little bit better and now
Oh, thank goodness.
Yeah.
So it just wasn't changing.
Yeah, last Saturday I just I was like kneel down to do my homework.
Oh no. That's awful.
Thank you for letting me do their presentation.
Sure. Oh, I'm glad you feel better, man. Oh man, that's rough. We'll see you later.
Yeah, I have to, like, for my tutoring job, I have to sit in another class for observing. That was horrible.
No, no. Well, I'm glad it got better.
I just got the insurance also.
Did they fix it?
Yeah, Barry just told me just to get an insurance right now.
They're gonna,
Yeah, but
everything should be okay.
yeah, good, good. Thank you.
Sir. We're doing 6 and
I was trying to read the chapter and I was doing the test and test.
didn't really match.
Yeah.
So chapter 6 is on me. So chapter 5 should have been like the first week because this was stuff that they actually did last semester, so that was review. Chapter 6 is the new stuff for us. It's not new for you. We'll also be looking at chapter 8 as the week goes on.
The chapter was multi-coding.
Find out when yes. So if you're doing the chapter that you've already done, and you wanted to try some experiments, and you say, so the way we have things split up, then C#2 focuses more on database aspects, like getting data from the database and doing that business stuff. And Java 2 focuses more on engineering, type things like multi-threading and stuff like that, which kind of disappoints some people once in a while. Like, there's only like so much that we can cover in the advanced classes, and that's just kind of the way they kind of split up. So we cover more multi-threading and multiple instances in Java, but they don't get a chance to do any database access. C# will get a chance to do all of the database access and all that stuff to do it, to do the multi-threading. Yeah, if it's something that you want to do, if you feel like some of these assignments are things that you've already done, let me know. Take a look at them and see what you think. Okay, I could give you, so let's see, the one that they do in Java, the first one is creating a chat. So you have two instances of the chat program running, one behaving with the client, one behaving with the server, to send messages back and forth. So I don't know if that would be actually, it is a little bit of data that could cover from a lot. So it could be from chapter 6. It could be from chapter 5. And when we get to unit exam, we can also include interfaces. Way too far into chapter 8. So 5, 6, and 8. So the test bank doesn't match up perfectly with your book. So that's why you have to practice acceptance. So try to get those practice things pretty deep, because some of those questions are things that have come from all sorts of different places. So you might not see it specifically in my book. Our textbooks do not supply a question bank. Those low rights. So we've got questions just from all over the place. So that's why you're not seeing them. You are exactly right. So look at those practice quizzes. A lot of people will go into the practice quiz and just go to the end and submit. So then it shows all the right answers, and then they'll copy and paste that and use that to study. So some people get to do it that way, because there are a limited number of questions in the question bank. So there is a chance that you wouldn't see them all in a practice test, since it's going to be in one. But if you do choose to practice tests, you probably will have all of them. They're not huge questions. But that's why you're thinking this doesn't match up, because you are right. Just throwing you there, making a mess out of everything.